this video will help you with your homework on Pizz 212. And let's just do a few of these together. Let's do a problem like, let's see. Yeah, this is a combination of multiplying and adding. So let's do a problem like number 5. We'll do this together on the video. So here the operation between the two expressions is multiplication. So I don't have to be as concerned, I don't have to worry about having like radicands. But the way you would do this, -5 times +4 is -20. And then underneath the radical, I'm going to have 3 times 6. So that's going to be -20 times 18. And then that's going to be, I'll do this in all the pieces. 18 has a perfect square of 9. And the square root of 9 is 3. I would multiply that by the 20 that's already sitting out there. And that would become my simplified answer for a problem like number 5. And let's look at number 9 since it's on the screen. Number 9. There are several ways you could do this. I could take this and rewrite this as 5 over 40. And then I could think of my radical as being 1 over 8. And then I could think of that as the square root of 1 over the square root of 8. I could simplify radical 8, but I know that I have to deal with rationalizing the denominator. So I'm just going to go ahead and think of it as this. I have the square root of 8 over the number 8. And now I'm going to simplify the radical 8 as it sits in the numerator. So I'm going to have 2 radical 2 over 8. And since the 2 in red and the 8 in red share a factor of 2, my simplified answer is going to be radical 2 over 4. And then I would stop. And I cannot simplify, cannot compare the 2 under the radical with the 4 that's not under the radical. What's under the radical is off limits. Okay, let's look at problem number 13 together. So problem number 13, I'm still multiplying. And I'm going to multiply 3 times 5 on the outside. So this is now 13 that I'm doing. Let me clear all the ink away. Okay, so I'm now going to look at problem number 13. And I'm going to multiply 2 times 5. And then under my radical, well, 2 is not a perfect square, and neither is 14. But I know where I'm headed with this. So I'm going to think of 14 as 2 times 7. And then with my variables, I have n cubed plus 5. I'm going to add those together. And then I'm just going to have t raised to the power of 5. So along the way to combining this and cleaning this up a little bit, here's my perfect square pairing. So I bring the square root of 4 out, or bring one of the 2's out. So that means that I'm now going to have 30 sitting out here because I have to multiply it by the 15 that's right there. And inside my radical, 7 will remain. And I'm going to have n under the radical now raised to the power of 8. And t, the perfect square, the largest perfect square factor of t is t to the 4th. So now I have my variables arranged with perfect squares. So I copy the 30 over. And the 8 comes out. 8 divided by 2 is 4. And then the 4 right here, that comes out as t squared. And then what remains under the radical is 7 and then t to the 1st. Okay, let's look in here and see what we've got. Let's look at number 3. Well, actually, number 3 is pretty good. Let's look at number 7. Let's look at number 7. So I have, actually that's not too bad. It was just the variables that makes it look a little bit intimidating. But radical x, they're like terms. So I would end up with 7 of those. And you can't do anything else with that because radical x and radical y are not like terms. So you would be finished with that problem. That would be as simplified as it could get. And let's see, it looks like the other problems here are just simply rationalizing the denominator. So number 4, let's look at number 4. And the 24 on top is not under a radical. So what I would do with this is just simply multiply by radical 6 over radical 6, just to get rid of the 6 that's sitting in the denominator of that fraction. And so now I'm going to have this. and the radical times itself is just the number on the inside. And then you can simply clean this up. And remember, what's under the radical stays under the radical if it's in its most simplified form. And let's look at number 16 on the video. Okay, let's look at this. So here I have 3 radical 2, and I'm going to go ahead and clean this up. Let's see, that's 25 times 3. So I'm going to clean this up as 10 over radical 3. Square root of 25 is 5 times the 2 that's already out there. That gives me the 10. And I can't simplify the 3 and the 10 that are sitting out here, so I'm just going to go ahead and rationalize this denominator. And remember, I'm only concerned about the denominator. It's okay for the radical 2 to stay in the numerator. And now carrying on, I have 3, and I'm going to multiply the 2 and the 3 together underneath the radical. And I have the 10 that's sitting right here, and I'm going to multiply that times that product of the radical times itself. And so now I have this. Well, actually, before I even do anything, the way that I've presented this, I can see that the 3's will divide away, and my simplified answer becomes this. And remember, what's under the radical stays under the radical unless the radical is not as simplified as it can possibly be. So don't be tempted to simplify the 6 and the 10 because they share a factor of 2. The 6 is under the radical, so it is off limits.